Okay, so I had to make two separate videos. Okay, but that's fine. So let's see if you had a quadratic that's linear, and then your linear quadratic that's linear, and then we wanna see what the solution is to the system when we didn't have a graph. So no graph, right? And someone said to you, I want you to tell me what the solutions are without having shown you a graphical representation. So I have these two equations. Now, we want to know where they're the same, right? At what points are these the same? So therefore, let's set them equal to each other. Set them equal to each other. Okay? So now, we have 6x. We want to know where they're both the same. Equals x squared minus 7x plus 12. So that's what I have now. So I took this just to make sure. I took the example from one of the checkup questions. That way you can get kind of like a little head start, and you can see where I'm coming from. So now let's solve this the only way we know how. So we have a quadratic and we have some term on the left side. So how do we solve quadratics? Well, you've already learned how to solve them. We can either factor them, we can use the quadratic formula, or we can use completing the square. We want to see what x values make these the same. So to me, I think factoring would be easier. So let's check that. So let's subtract this, and we're gonna set this equal to 0. So we're gonna subtract this from both sides. So now I have 0 equals x squared minus 7x plus 12. 0 equals x squared minus 7x plus 12. So now, okay, we're going to factor this and set it equal to 0. So now, oh wait, hold on. That's not minus 7x. That should be minus 13. Minus 13. Okay, my bad. Okay, so now, what multiplies to positive 12 but adds to negative 13? Well, I know 12 times 1 is 12. Okay, that's positive, but we have a negative middle term. So then the only thing I can think of has to be is x minus 1 and x minus 12. These will give me two negatives make a positive, and then the negative 1 plus negative 12 gives me the negative 13, and that's equal to 0. So now that I have two separate factors, I can have two separate equations to solve for x. Now I have x minus 1 equals 0, and x minus 12 equals 0. So here I have x equals 1, x equals 12. Now, these are my x values, where they would be the same. But now I want to know what the y values would be. At what y values will these inputs, or these x values to the solution of the system, will give me the outputs, or the y values. So, to me, this would be easier to plug it into the 6x. So let's do that. So we'll put this to the side. We're going to plug in x equals 1 and x equals 12 into the linear equation. So now we have y equals 6 times 1. So y equals 6. So then that means at 1, 6, at 1, 6 is one solution to the system, to the nonlinear system of equations. Okay, and then I have y equals 6 times 12. Okay, and then see what, and then y equals 6 times 12, 72. So then at 12, 72 is another solution. Another solution. Another solution. So that means this nonlinear system has two solutions. Okay, and they're at 1, 6, and 1272. So let's check that. Let's go back to my graph. I can graph these on the website I gave you, and if you want to, you can use it as reference. So I graphed I inputted the two equations into the website, okay, and then I have at 1, 6, like there's one. Okay, so we got one of them, right? So let's go up here because the graph goes up here somewhere. Look, they're eventually going to meet at, look, 1272. So we were right. At 1272 and on 1, 6, they're solutions. So if I can just zoom out a little bit, listen to this. Okay, so there's one here, up here, and then one down here. So you can mess around with this website too if it helps, and we saw those solutions there. So hopefully this helps you with your assignments, and let me know if you need any help on Google Classroom. Okay, have a good day.